In the last few lectures, we have seen what are energy signals, power signals, and neither energy nor power signals. And we already know how to find out if the given signal is energy signal, power signal, or NENP signal. The first step is to find out the average power. If the average power P is equal to 0, this implies the signal is energy signal. And if the average power P is some finite value, this implies it is a power signal. And if the average power P is not 0 and not finite, this means it is infinity. This implies it is neither energy nor power signal. But we will not perform the calculations. In this lecture, we will not perform any calculation. We will not calculate the average power P, but we will directly try to find out if the given signal is energy signal, power signal, or neither energy nor power signal. On your screen you can see 9 different waveforms, and we will try to find out what type of signals are they one by one. The name of the lecture is shortcut for energy, power, and NENP signals. This name shortcut should not be there because we have discussed energy, power, and NENP signals in detail, and whatever we are going to do here we have already discussed in earlier lectures. So this is summary for energy, power, and NENP signals. We will use the conclusions which we have drawn till now to solve the questions without performing any calculation. Now I will start the discussion with energy signals. In case of energy signals, the total energy is finite. The total energy is finite, and when the total energy is finite, the average power is equal to 0. The total energy is finite in case of finite duration signals. In case of finite duration signals, the total energy is finite. The total energy is finite in case of infinite extension signals also. In case of infinite extension signals, the total energy is finite, but there is one condition here. The amplitude or the peak amplitudes must have the decreasing nature. They must be converging. So these are the two cases in which the total energy is finite. So whenever you see a signal which is finite duration signal, there is no need to perform the calculation. You can directly write down the signal is energy signal. And whenever you see any infinite extension signal in which the amplitude or the peak amplitudes are decreasing or converging, you can say the signal is energy signal. Now let's talk about what is this infinite extension signal. In case of infinite extension signals, the non-zero amplitude range is infinity. So this is one important point. In case of infinite extension signals, the non-zero amplitude range is infinity. So whenever we have these two signals, we can directly write down they are energy signals. Next, we will talk about neither energy nor power signals. I explained neither energy nor power signals in the previous lecture, and I told you if the signal is having the magnitude equal to infinity at any one instant, then the signal is neither energy nor power signal. So if any signal is there in which the magnitude is equal to infinity at any instant of time, the signal will be neither energy nor power signal. And if we have infinite extension signal, if we have infinite extension signal in which the amplitude or the peak amplitudes are increasing, then the signal is neither energy nor power signal. So there is difference between the infinite extension signal in case of energy signals and the infinite extension signal in case of neither energy nor power signals. Here the amplitude is having the decreasing nature, and here the amplitude is having the increasing nature. So whenever we have these two kinds of signal, we say they are neither energy nor power signals. Now what about power signals? We have three kinds of signals. The first one is the energy signal, the second one is the power signal, and the third one is the NENP signal. We have already seen what kind of signals are energy signals and what kind of signals are NENP signals. Now to find out if the signal is power signal or not, simply check if the signal is energy signal or NENP signal. If the signal is neither energy signal nor NENP signal, then it is power signal. So there is no need to worry about the power signal. Simply find out if the signal is finite duration signal or not, if it is infinite extension signal with decreasing amplitude or not, if the magnitude is equal to infinity at any one instant or not, and if the infinite extension signal is having increasing amplitude or not. If all these four conditions are not satisfied, then we can say that the signal is power signal. Now let's start with the solution of the problems we are having in this lecture. In the first case, we are having signal x1t, and you can clearly see from minus infinity to this point, the signal value is equal to 0, and from here to here, the signal value is finite. There is some finite value, let's say it is a0, and again from origin to infinity, the signal value is equal to 0. So we can say that this is a finite duration signal. From here to here, the signal value is equal to a0, and it is a finite duration signal, so we can say that it is an energy signal. Very easy. And even if you calculate the average power P for this signal, you will find it is equal to 0. So you can use the formula for the average power in case of non-periodic signals, and you will see the average power P is equal to 0. And from here also we can say that this signal is energy signal. Now let's move to signal x2t. You can see the waveform of this signal, and the right hand side of the signal is having the waveform which is increasing like this, and the left hand side of the signal is having the waveform which is decreasing like this. So in this case, the non-zero amplitude range is infinity, and thus this signal is infinite extension signal. And here the amplitude is not decreasing, but it is increasing. And when amplitude is increasing in infinite extension signal, it is neither energy nor power signal. So signal x2t is neither energy nor power signal. Let's talk about signal x3t. In this signal also you can see the non-zero amplitude range is infinity. So this is also infinite extension signal, but here the amplitude is decreasing. And when amplitude is decreasing in infinite extension signal, it is energy signal. So this signal here is energy signal. Now let's talk about the fourth signal, which is signal x4t. Here signal is finite duration signal, and hence the energy signal. Signal x5t is obtained by the help of step signals, and the right side of the signal is having some constant value, let's say a0. From 0 to infinity, the value of signal is a0, and the left side of the signal is having some value, let's say minus a0, and it is from minus infinity to 0. So this signal is not a finite duration signal, and this signal is infinite extension signal, because here also the non-zero amplitude range is infinity, but here we can see that the amplitude of the signal is not decreasing, and also it is not increasing. So this signal is not energy signal, and it is also not NENP signal. So this is power signal. This is power signal. Let's talk about signal x60. Here the signal is having the decreasing value with time, and as the signal is having the decreasing amplitude with non-zero amplitude range as infinity, it is energy signal. Let's talk about signal x70. Here the peak values, if you see the peak values, then it is decreasing with time like this. And as I told you, whenever we have the amplitude or the peak amplitudes decreasing, the signal is going to be energy signal. This is infinite extension signal with peak values decreasing, therefore it is energy signal. And the opposite will happen in signal x8t. If you see the peak values, you will find they are increasing with time. They are increasing like this. This is infinite extension signal with peak values increasing, therefore it is neither energy nor power signal. Okay, let's talk about the ninth signal, and it is very much similar to signal x70. If you see the peak values, you will find they are decreasing. It is an infinite extension signal with peak values decreasing, therefore it is energy signal. So in this way, there is no need to perform the calculation, and you can directly tell about the nature of the signal, whether it is energy signal, power signal, or neither energy nor power signal. If you have any doubt regarding this, you may ask in the comment section. Now we will discuss the next part of this lecture. If we have a periodic signal, then there are two possibilities. The first possibility is that the periodic signal is power signal, and the second possibility is that the periodic signal is neither energy nor power signal. Periodic signals are not energy signals because their energy content is infinite. For periodic signals, the energy content is infinite, and for energy signals, the energy should be finite. So there are only two possibilities. Either they will be power signals or NENP signals. Now let's see a few examples in which periodic signals are power signals. The first example is cos t, second example is sin t, etc. The example of periodic signal which is neither energy nor power signal is tan t. We have seen this in the last lecture. Now let's talk about non-periodic signals. Non-periodic signals, there are three possibilities. The first possibility is that signal is energy signal. The second possibility is that signal is power signal, and the third possibility is that signal is neither energy nor power signal. Now let's see one example in which the signal is non-periodic and energy signal. The example is e raised to power minus 2t ut. Now let's see one example in which signal is non-periodic and power signal. The example is simple step signal. Here we have unit step signal because a naught is equal to 1. Now let's see one example in which signal is non-periodic and NENP signal. The example is ramp signal. We can also have other example which we have seen in the last lecture. It is 1 by t. These two examples we have already seen, and we have seen that the signal is neither energy nor power signal, and also it is non-periodic. Now let's talk about finite duration signals. Finite duration signals, there are two possibilities. The first possibility is that the signal is energy signal, and the second possibility is that the signal is neither energy nor power signal. The power signals are having the extension equal to infinity. The extension of any power signal is infinity, so finite duration signals cannot be power signals. Now let's see one example in which the signal is finite duration signal and also the energy signal. I will quickly draw the waveform of the example signal. This is minus 2, 2, and let's say this is 4. So you can see the signal is having the finite value from minus 2 to 2, and it is equal to 4. So this is the example. Now let's see one example of the finite duration signal which is NENP signal. This is important case. In this signal, from minus 2 to 2, the signal is having some value, and when we approach towards the origin from left side and from the right side, the value of signal approaches to infinity. And we already know whenever the value of signal approaches to infinity, it is the case of NENP signal. So we have finite duration signal, but it is NENP signal. So this example was an important example. Now let's talk about infinite extension signal. Infinite extension signals. Here we have three possibilities. The first possibility is that the signal is energy signal. The second possibility is that the signal is power signal, and the third possibility is that the signal is neither energy nor power signal. I will write down the examples quickly. Here the example is e raised to power minus t ut. It is an infinite extension signal with decreasing amplitude. For power signal we have ut. Again, it is an infinite extension signal, but the amplitude is neither decreasing nor increasing. And if you remember the signal x5t, we saw it is power signal, and it is the combination of step signals. And if you have a step signal, like this, and let's say it is unit step signal, Then also the signal is infinite extension signal, but the amplitude of the signal is not decreasing and also not increasing. So it is not the case of energy signal, and it is also not the case of NENP signal. So it is power signal. So we have seen the example of power signal, which is infinite extension signal. Now let's see the example of NENP signal, which is infinite extension signal. It is ramp signal or 1 by t square. We have seen these two signals in the last presentation, and they are infinite extension signals with increasing amplitude. So this is all for this lecture. If you have any doubt, you may ask in the comment section. This was one complete summary of what we have learned till now regarding the energy signals, power signals, and NENP signals. I will end this lecture here. See you in the next one.